mistakes. Time is going to be an issue, right? You have an hour, 15 minutes. How many problems is this? 9? I would say probably 6 or 7 problems. Yeah. I mean, wouldn't y'all prefer to have 6 over having like 10? I mean, it's taken me almost the entire class to go through this, and I know what we're supposed to be doing, right? When you're reading that word problem in the back about the fence and stuff like that, it's going to take you some time to like figure out what's going on, you know? So these hour, 15-minute classes are so short. It's hard, well, short relative to the calculus classes are hour, 40 minutes. So, all right, number 4. A clothing company has determined the price-demand equation for a particular style of pant is blah. Find the extrema for the revenue function. So we've got to come up with the revenue function, right? We've done this several times now. Revenue is x times price. So my revenue is going to be x times 56 minus 0.15x. I can distribute the x through and get 56x minus 0.15x squared. Derivative, right? Set it to 0. Test points. We want to know the extrema. We want to know where it's going up and down or down and up. What's my derivative? Is it 56 minus, what's that, 0.3x. Set that to 0. So what do we get there? 186.6 something? 7. Good enough. Okay, good enough. Number line, 186.6. Testing, and we will get revenue going up and then down. Yes, up and then down. I'm not plugging in the test points because, again, I'm trying to work fast here. Have I done enough of these? Have we done enough of these? All right. One here, I'd probably plug in 200, and I plug those into the derivative, right? Into the derivative. I only have one extrema, right? I only go up and down. I don't go up, down, then down, back up. So I only have one extrema. I have a local max at x equals 186.6. That's all at once. I've answered part A. It does not ask for the value, right? Local maximum at 186. Now, if you wanted to know what the maximum was, you would just take that number and plug it into what? The original revenue function, right? Okay. All right, what about part B? On which intervals is the revenue function concave up and concave down? So how do we do that? Take the second derivative. All right, so to work out part B, I need the second derivative. What is the second derivative of this function? Negative 0.3. And that's it, right? That's it. Oh, look, it's this derivative, that's 0. Derivative of this is that. What is that telling you? The second derivative is negative, right? Always. Regardless of what x I plug in, there is no x in the second derivative. The second derivative is always negative. That means it's always concave down. That's what this says. Okay? So the answer to part B is that the revenue is concave down. Why is it concave down? Not up? Because that's a negative number, right? Concave down on the interval negative infinity to infinity. So it's always negative, always concave down. So what if, just for the sake of making sure you understand this, what if this had turned out to be negative 0.3x? Then you would set that to 0 and do test points. Okay? That okay? We good? What about number 3? Yep. I think 3 we can work pretty quick, can't we? Let's see if we can work 3 quickly. All 3 is asking for is where it's concave up and down, right? That's all it's asking for? Well, in inflection points. Do you remember what an inflection point is? Where the concavity changes, right? Where you go from concave up to down or down to up. Okay, we only need the second derivative here, because all it's asking for is concave up and down. So first derivative is negative 3x squared minus 10x plus 4. I'm trusting you can do that. Second derivative is negative 6x minus 10. That's the one we set equal to 0. So my second derivative equal to 0 means that I want to take negative 6x minus 10, set it equal to 0, and I should get x is negative 10/6. What is that? Yeah, negative 1 point. We'll go negative 1.6. All right. X is negative 1.6. Oops. What do we do now? Test points, right? We need to plot that on number line. Negative 1.6. So I can pick something like negative 2. And I'll plug in 0 over here because 0 is on this side. Where am I plugging those numbers into? The second derivative. So plug them into here. What happens if I put negative 2 right here? I get positive 12, take away 10, that's going to be a positive number, right? So that means my original function here is concave up. And if I plug in 0, it's going to go the other way, so it'll be concave down. So go ahead.
So the only inflection point would be negative 1.
You only have one inflection point right here. So if I were answering the question, where is it concave up? Negative infinity to negative 1.6. Where is it concave down? From negative 1.6 to infinity. These are the intervals. To the left of negative 1.6, I'm concave up. To the right of negative 1.6, I'm concave down. The inflection point, I'm going to put IP for inflection point. Is that okay? Is x is negative 1.6. Those are the 3 things that we're being asked for. 6 minutes or so. Let's look at number 2. Any questions on this before I erase it? Okay. Y'all tired yet? Welcome back. Hope you had a good spring break. Yep. Okay, so this number 2 is a little messy because it requires the chain rule to take the derivative. So I give you that y is equal to x squared minus 16 to the 5th power. Let's see if this looks familiar. When we were doing this, I think I did this, where I kind of covered up this inside part, and I said, what would the derivative of that thing be? like this to the 5th power. So if you have something to the 5th power, the 5 comes out, right? That's your power rule. So I'm going to say 5 comes out, and then you do not touch the thing inside. You don't mess with it. You bring the 5 out, you reduce the power by 1. Then what, though? You're not done with the derivative. You need to
Find the derivative of the
okay, so now you take derivative of the inside. What's derivative of the inside?
2x.
Just 2x, and you attach it to this with multiplication. That is your first derivative. That look familiar?
Yes.
Okay, now I'm going to clean it up a little bit. I'm going to put the 2x out here in front with the 5 and make it 10x. And then now just rewrite this like this. Okay, so this is our first derivative. That's it. Now we want the second derivative, which means we need to take derivative of this. And I heard it. You have to recognize that you now have a product right there. And the product rule said this. If you have two things being multiplied, that the derivative is f prime g plus g prime f. That was the formula that I gave us in class. So that means you have two functions. 10x is one of them, and then this is the other one. So my second derivative should be the derivative of the first one, right? Derivative of this one. So just 10 times the second one without a derivative, right? So that'll be your x squared minus 16 to the 4th power. That would be f prime times g. Then you say plus, now you take derivative of g, which is derivative of this right here, right? Which is just like what we did up there. You have to bring the 4 down. Don't touch this and make it to the 3rd power. So I'm going to bring the 4 down. Don't touch that to the 3rd power. Now you take derivative of what's in here, which is 2x. Tack that on. And then I'm not done. There's one more thing. I have to slap the f on the end. And the last part is what? What's the f? 10x. So this was f prime times here's g plus this whole thing right here is g prime, and then times this part right here is f. So those are our little right there. I don't know if that makes sense. And if you can get to that point, I'll be happy. I'll give you full credit on that. If you want, you can if you want, you can put these together out here, but I'm going to be looking that you can just get to that. Okay, I don't think I have time for number 1. I think number 1 is straightforward compared to, the others. So on Thursday, make sure that you are here on time. You can use a cheat sheet, but you can't work out problems, okay? So don't just go work this whole thing out and put it on cheat sheet. Formulas, steps and procedures, nothing worked out, okay? All right, I'll see you on Thursday. Y'all have a great day. Everybody has a copy of this? All right. Yes.
Where did the 2x come from? This one. Where did that come from?
Okay, so what we have to do is we bring the 5 out, right? And then we don't touch this. We leave it alone, and we reduce the power by 1.
Okay.
After we've done that, so we've already dealt with the 5, right? So I'm just covered up. Now what we need to do is we take derivative of this. Derivative of this is 2x. Okay. Derivative of that is 0, right? So that gets tacked on.
Okay, same thing for where did it come
Yeah,
out?
now here, same thing. When we were looking at this piece, we brought the 4 out, reduced the power to a 3. Then we said, okay, I did the 4. Take derivative of what's in here. Here it is again.
Okay.
Okay?
Makes a lot more sense.
I know there was this, and then there was like the last question.